Hello, grade 8 math. This is lesson 6.2, solving equations using algebra. So in this, what we're going to do is we're going to use a model parallel to the algebra to kind of show how these line up with what we did last lesson was the model, and this lesson is going to be using algebra, which is this is the way that you're going to be using it most of the time, unless you choose to take time to draw models that typically take a lot more time. The goal in this is to isolate the variable on one side of the equation. In other words, we try to isolate. Have you heard of someone in isolation? They would be all by themselves, right? So we're trying to get that variable, which is that letter or symbol that represents some number. We're trying to get it by itself on one side of the equation with no numbers there, no operation signs or anything, just by itself, and the other side will have what it's equal to. So what we're going to do here is look at this example, and I'm going to do the model on this side with algebra tiles, and on this side I'm going to do the algebra, and if there's room I'll also do a little bit over here where it's what I'd actually expect you to show as you do your work. The middle will be more of the full explanation. So to start off, let's look at this question. It says that George charges $2 for each bag of leaves he rakes and $4 to mow the lawn. He made $12. And we need to first write an equation that represents this problem. So just looking at this, it says that George charges $2 for each bag of leaves. Well, each bag of leaves right there tells us that there's going to be some number of leaves, right? That's going to be our n, right? We're going to have some number of leaves. And how much gets charged? Well, $2 for each of those, right? So $2 times the number of bags that it is. So to start off, our equation is going to be 2 times n, the number of leaves that it is. And then it also says $4 to mow the lawn. Is he going to need to mow the lawn a bunch of times on that same day that he rakes the leaves? He's going to rake the leaves, a bunch of bags might happen, and he'll charge the money, and then $4 to mow the lawn. He's only going to have to mow the lawn once that day. He'll wait a couple weeks before he mows it again. So that's $4 more that's going to be added no matter how many bags of leaves there are. So it's going to be plus 4. And then it says he made $12. So all of this stuff added up is going to equal $12. So there is our equation. So first things first is to get the equation if you have a word problem. And then I'm going to take this and I'm going to draw out the model using algebra tiles. So there's two ends, so I'm going to draw two ends. And I'm going to draw also 4 positive blocks here. I also have my equal sign, so I'm going to draw the line down from it. Then I have 12 tiles here, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to do it this way. Sometimes these don't end up looking that neat by the end, but hopefully yours is good. So 2 of these variables, and then a bunch of individuals, 4 of them, and then 12 on the other side. So what you would draw when you're doing the algebraic way is actually just this first line here, our equation. So this and this will be the same. It's 2n plus 4 equals 12. Just going to draw a little line between these so that I keep them separate. And step by step, I'm going to draw a line across. I'm going to leave a little bit of space on the side to do something at the end. Looks like my marker's dying. I'm going to get a new one. All right, I have my new marker. So that's the first step. When we were doing our tiles over here, algebra tiles before, now instead we can just use some numbers and represent it that way, and it works a lot better. Now what we would have done with the algebra tiles over here, our next step would have been to to subtract some tiles by putting in some negative tiles over here. So what I'm going to do next is do that. I'm going to draw it out. So I've redrawn it here, and I'm going to put in the exact same amount of negative tiles here as there were positive tiles. And because I did that to this side, in order for this to still be equal, I need to also do it to the other side. So I'm going to draw those in, the same amount of negatives there. So that means that now on this side, we have 2n plus 4, subtract 4. Right? And then on this side, we have 12 and subtract 4. Now we're going to cancel some of this out in our next step, which I'm going to draw. Our next step is to remove these here, right? We're going to take these 4, we're going to remove them. We're going to take these here, 4 and 4, and we're going to remove them. And what remains? Well, we have 2n that remains, and that equals 8. Which I decide to draw below. I have 2n, right? What wasn't removed, and I have 8. And then what we're going to do here is divide both sides by 2, aka we're going to divide it into those groups that are those single variables. And how many groups do I have? 2 groups. And so that means we're going to divide both sides here by 2. And when we do that, we are left with 1n equals 4. So to look at this and to put this in the way that I'd want you showing this, I'm going to do it just here on the side, up at the top, and we'll refer to it as we go. You're going to start by writing down your equation that you come up with, just like we did to start. And then you're going to take away 4 from both sides. You can either write it in like this, but what I often like to do is to just write down, so find my the constant that is not with the variable, this add 4, subtract 4, whatever it is, and do the opposite of it, so subtract 4, subtract 4. And I'm just going to write it below. Why? Because this cancels out and makes a 0, and then I just have to go 12 subtract 4 and leave in what is there. So then next, down here was 2n equals 8. So if you think about it, what's left over? There's 2n here. That becomes 0 and equals 12 subtract 4, which is 8. And the next step is to divide both sides by 2. So I'm going to draw that in. I'm just going to divide both sides by 2. And 2 divided by 2 is 1 times n would just be n. And 8 divided by 2 is 4. And there is our answer. On some of the questions you get, you will be asked to verify the solution. So I'm going to do that right now. And remember, to verify, you just write down your equation again, but replace n with what it's equal to. So it becomes 2 times 4 plus 4 equals 12. Remember, n equals 4, so that's why it's replacing the n. And that becomes 8 plus 4 equals 12. And indeed, 12 equals 12. So it's verified. If these numbers are not the same number, it is not verified, which means you would have made a mistake and your answer that you're using was wrong, or you did some math wrong in the process. So why isn't a model good enough to do and just do it that way every time? Well, sometimes you're going to have a little bit of trouble doing it. Why? Because there's some numbers that are large, right? And drawing the model over and over a bunch of tiles 69 times, for example, here would be difficult. Also, some of us just honestly don't like the model method. Some people find it confusing, more confusing than just doing the math this way. So we're going to do a bunch of examples here that are using the method I just showed you without the model. So 16t subtract 69 equals negative 13. For example, you're going to do something 16 times, but not sure how much of that thing it is. Maybe your grandma gives you 16 bills and takes back $69, and you're left with negative $13, which means she took more than what it was. That might be what this question is. Who knows the real world situation? Let's just look at the math. So first step is to deal with the constant. We're going to deal with this negative 69, and we're going to get rid of it by doing the opposite operation to it, which opposite of subtraction is addition. So we're going to add 69 so that this becomes 0. But because this is truly an equal sign, we needed to do that to the other side. We also need to add 69 to this side. Whatever we add to one side, we have to do to the other. And so we're left with, over here, 16t. And notice that I like to draw it basically right below so that my equal sign is still in a row, and I can see what part is changing when I look at a math question later. Then I have 13 plus 69, 13 plus 69. Sorry, negative 13 plus 69, which is also known as 69, subtract 13. So I'm going to be left with 56. All right, now that we have 16t equals 56, we need to get this t by itself. And remember, the variable right beside numbers, that means they're being multiplied. 16 times t. So the opposite of multiplication is, oh no, another marker dying. 16, oh no, it just kind of dried out when I paused the video. So then 16 divided by 16 is 1 times t is t. So we're left with t equals 56 divided by 16. Oh, it doesn't divide quite evenly. This fraction, for example, can divide by 8 and divide by 8, and I'm left with 7 over 2. So t is actually 7 halves, or 3 1/2. We're going to use 7 halves. It's easier to do the math if you leave it in an improper fraction to do the verification. So we're going to verify this. Let's go down here and write in our equation again. 16 times what's t? Well, it's 7 over 2. And we're going to subtract 69 equals negative 13. So to do the math, well, this is just like 16 and 7 halves. So we go 16 times 2 is 32 plus 7. Sorry, I just got distracted for a moment there, and I'm not sure what I was saying here. 16 times 7 over 2. Well, a couple ways you could do this. You could take 16 and divide it by 2, which that's the method that I like to do. I'm going to take 16, divide by 2, and that becomes 8 over 1. And so then all you're left with is 8 times 7. 8 times 7 is 56. And then that cancels out there, right? And then 69 equals negative 13. If you don't know how to do this, please ask me. And then you've got 56 subtract 69. Well, 69 subtract 56 is 13. Because the negative is bigger, it's negative 13 equals negative 13. And that is verified. Some of the questions will have fractions as your answers, some won't. When they don't, it's actually quite a bit easier to verify. Let me explain it this way. If you have 16 7 halves, so 16 times 3 1/2, if you do the math, what's 3 1/2 here? 16 times 3 1/2, you'd end up with 56. Another way to look at this, the division and multiplication, the order you do them in doesn't matter too much. So if you wanted, you could have done 16 times 7 and then divided by 2, and you would have ended up at 56 as well. So there's a few different ways here. I like doing this way where if I have an even number, I divide it by 2. It's a little simpler for me, and then just multiply it by the top. Let's do another example. Hopefully it'll be a little bit simpler of an answer, and then verifying will be simpler and hopefully make more sense. All right, what about this? 14h subtract 12 equals 968. Well, first step, get rid of this negative that is with our variable here that we don't want on this side. We need to isolate a variable, so opposite of subtraction is adding. So add 12, but what I do to this side, I need to do the other, so I'm going to add 12. And so I'm left over here with 14h, and then 980 right here. Then I need to divide both sides by 14. Why? Because I need to get rid of this 14 times h. And if I do that to that side, I need to do it to this side, and I'm left with h equals 980 divided by 14, which is 70. Just gonna check with my calculator. I think I did that right. 980 divided by 14. Yes, it is 70. Wow, my mental math's checking out. Awesome. So check it out. Go 14 to verify it. 14h. H is 70. Subtract 12 equals 968. 14 times 70 is 980. Then we're going to subtract 12 equals 968. This is 968 equals 968. It is verified. Here's another. 1 equals 10, subtract 3x. Well, what if variable's on this side? Doesn't matter too much. We'll figure it out. We're going to get rid of the thing that is here with the variable and coefficient term. So we're going to get rid of 10. How do you get rid of 10? You subtract 10. What you do to this side, you must do to the other side. So subtract 10. What is 1 subtract 10? Well, it's negative 9. What's left over here? There's the subtraction sign and the 3x. So subtract 3x. Now, looking here, we need to divide both sides by what? We need to divide both sides by the coefficient, which isn't just 3, it's negative 3. So divide both sides by negative 3. Divide this side by negative 3. And by doing so, you're left with x over here. And what are you left with here? Negative divided by negative is going to be positive. 9 divided by 3 is 3. So x is 3. If you want to switch this so that it's on the other side and say x equals 3, I do like that. Having the variable on the left side doesn't matter too much to me though. Here is 1 equals, I'm going to verify here, 1 equals 10, subtract 3 times, well, x was 3, so times 3. 1 equals 10, subtract 3 times 3 is 9. 10 subtract 9 is 1. So 1 equals 1 is verified. Put a little check mark or V just there. Let's do some more examples. If you want to start working on your assignment, you could if you know how to do this. If not, keep watching some examples. There you go. Negative 8x plus 11 equals 59. First thing is to get rid of our constant. So get rid of 11. Why? Because positive opposite is 11. This will equal 0. So we're left with negative 8x equals 59 subtract 11. 59 subtract 11 is 48. And then simply divide both sides by 8. No, not 8. Negative 8. It's that whole thing there. Negative 8. Divide both sides by negative 8. You get x equals, well, positive divided by a negative is negative. They're opposite signs, right? And 48 divided by 8 is 6. So x equals negative 6. So let's verify. Negative 8 times negative 6 plus 11 equals 59. Well, negative times negative is positive, so 6 times 8 is 48 plus 11 equals 59, and voila, it is verified. That is what we're doing here this lesson. I hope that it works for you. Just to go through the steps, or maybe just a little diagram here. This would be known as our coefficient. This is our variable. This is our constant. and this would be product or sum, depending. So first step is to remove constant by either addition or subtraction. Do the opposite. And then 2 is to remove coefficient, which is either division or multiplication. And that should isolate your variable. All right. Have a great time working on your lesson.